Okay, Bismillahirrahmanirrahim. Let's continue uh, with the ensemble methods lecture. So yesterday we looked at the give me a second. So yesterday we started looking at ensemble methods, and the first technique that we studied yesterday was bagging. And in bagging, to briefly go through it, we create K bootstrap samples, and after doing that, uh, we train independently K base classifiers on each one of these K uh, data sets, these bootstrap data sets. And then finally, given a new uh, test example, we decide or we make the prediction using the averaging or the majority voting, right? This was in the case of bagging. And random forest is one example of bagging where you have the base classifier is the decision tree, right? Today we are going to look at another technique which is called boosting. How is it different from bagging? One, it is in boosting, the base classifier would be trained sequentially, and in each it would be trained sequentially, and then uh, we will be using the whole data set, and rather creating multiple overlapping training sets. In this, what we are going to do is to iteratively reweight the training examples so that the examples which were wrongly classified in the previous round are given more weightage. Okay, and this is how we are going to train our base classifier sequentially by reweighting the training examples. What we're going to look at today is this algorithm AdaBoost. Uh, so what is this AdaBoost? So let's say we are given a base classifier, which we are going to call a weak learning module. Because in case of AdaBoost or boosting, what we need is a weak classifier which can get us this, which can give us which is better than random guess. You know, the random guess is 50%, but here what we are saying is that our base classifier should be a little better than the random guess. Now the question is, can we apply this boosting technique, or can we apply it multiple times, this weak classifier, to get a strong learner, or how can we do that? That is, how we basically, that is what is this AdaBoost does. It applies uh, this weak learner or base classifier multiple times to get a strong learner. And each time, what it is going to do is it is going to look at harder and harder examples. By harder example means that in the first, let's say, round, uh, the examples that I could not classify rightly, they are given more weightage in the next round, and so on. Okay, and this is how ultimately uh, I will be looking in the final round. The base classifier would be looking at the examples which are the hardest. And finally, the final classifier would be the weighted sum of the component classifiers. So at each round, I will be applying my weak classifier. So the final classifier would be based on the weighted sum of all the classifiers, of all the component classifiers. Okay, so let's go into the detail. First, these are the steps. The first step is first train the base classifier on all the training data with equal importance weight on each case. So if you have, let's say, 10 examples, and each one of those will have equal weight. And just like before we are training a classifier, we are going to train a classifier. And then in the next step, we are going to reweight the training data to emphasize the hard cases and train a second model. ठीक है, तो we will look at कौन सी examples थी जो कि wrongly classify हुई हैं, and then we are going to retrain the model on on all examples, but the weights of the harder cases would be more than the weights of the easier cases. How to do that, actually, that's coming next. Okay, once we do that, then the third step is keep training new models on reweighted data. Okay, so step 2 and 3 would be repeated again and again. And finally, so this is going to be repeated again and again. The step 4 is finally use a weighted committee of all the models for the test data. So the models that have been trained once you repeat the step 2 and 3, in the fourth step you're going to use all of them, but you will have some mechanism to give different importance, different weight to different classifier, and using that, then you're going to use a weighted sum to get the final output. Okay, so basically, how to actually do that? How do we concretely? Let's say my input is X, output is this is the output. We're talking about binary classification, and this is the target. Target means this is the ground truth label that we want to achieve for a given X. We're going to start with all So let's denote the weight of an example by this scalar value W. The subscript would indicate ये कौन सी example है, ठीक है. N means it is nth example, and the superscript indicates कि कौन सा classifier है. Let's say first round classifier, second round का, and so on. ठीक है. The superscript is for the classifier, and the subscript is the example number. So initially, all examples would have to start with, we will have same weight for all the examples. Okay, so the cost function for the classifier M. So what is the cost function? The cost function is given by this equation, where n goes from 1 to capital N, where capital N is the total example that we have in the data set, and this is the weight of the nth example. And so since we are doing it for the mth classifier, so the M is there for that, and this simply indicates that the classifier output. So why M is the output of the classifier, of the mth classifier for the data point X. If it is not equal to the true value, then this indicator function would be 1, otherwise it would be 0. So for all those examples where you are wrongly classifying, or where your output is not equal to the target value, you have 1 output, otherwise you have 0 output. Okay? So basically what you're doing is you will then be adding, depending on whatever the weight is, you will be adding those values. So obviously if the weight is less, even if you are wrongly classifying, effect would be less. But if the weight is, for that particular example is really high, and if you have wrongly classified that, it would have a significant effect on the cost function. Okay, so this is how we're going to go. This is my cost function. Then the equation to compute the weighted error rate is given by this equation here. So basically it is the cost. So this one is simply cost, but then we divide by the sum of all the weights in the training set to get a normalized, a weighted error rate. So this is going to give you the error rate, and the quality of the classifier is going to be computed by this equation here. Basically, what this equation is telling you that if it is zero, if the classifier has weighted error rate of 0.5, and infinity if the classifier is perfect. Okay, so and finally, once this is for the first round or any round. For the next round, you're going to reweight your example using this equation. So, I mean, I'm not going to go into detail, but what this equation is going to tell you is if you're wrongly classifying, the weighted would be bumped up, the weights of the example. Otherwise, they would be the weights would be reduced. For the example, if you are classifying them right. Okay. And so once you have trained, finally, this is how you're going to compute the output. So इसमें you have the output of the mth classifier multiplied by its quality or its weight, and then you take the sum of all those outputs and take the sign. ठीक है, if it is plus sign, you assign it plus one class. If it is negative, you assign it the other class. Okay, let's look at this example. So for example, this is your training data. Okay, and you have a very weak learner that gives you better than a random guess, slightly better than random guess. So you apply it initially, and let's say this is the boundary you get. Okay, on one side you have positive, on the other side you have negative. So these data points you have made error. Okay, so you are going to give them more weightage. Okay, so the size of the plus indicates that I'm giving them more weightage. The size has decreased here, so I'm giving less weightage to them because they were rightly classified. Similarly, this was also rightly classified. So only these three were wrongly classified, so I'm giving them more weightage. In the next round, I'm going to again train a classifier, and using this new data set in which the weights have been changed according to the equation that we discussed in the previous slides. And I am also keeping track of the weighted error rate and the quality of the classifier. So the weighted error rate of the first round is this, and the quality of the classifier, this classifier is given by this alpha 1. In the second round, this is what I get. Okay. So this time, those examples जो कि पिछले राउंड में गलत हमने क्लासिफाई की थी, उनको तो हमने सही क्लासिफाई कर लिया, बट ड्यू टू but there are some other examples now which I have wrongly classified. For example, these three. So in the next round, these are given more weightage now. Okay, and so this is how I'm going to have the line. So this B classifier is the linear classifier that I'm using. So I will always get a line, and so this is for the third classifier. This is how my decision boundary would be. So this is the first classifier, second classifier, third classifier. These are their quality. So so this is the final, my equation to compute the final output. I'm going to take this is the output of the classifier, of the mth classifier, multiplied by its quality, and taking the sum and finally the sign. So this is what I'm doing here also. Okay, this is the first classifier, second classifier, third classifier. They are multiplying them by their quality. You get the output of the output of the classifier is multiplied by their quality, and then you add them up and take the sign to get the final prediction. And this would be my final prediction. Okay. Another example, you can also go to this applet to actually see, visually see how things change, how the weight change, and how the same boundary change as you iteratively go through this AdaBoost learning procedure. Okay. Any question? This is the overall algorithm. We have the input, and we start with the weak, and we are given a weak learner. Weak learner can be even you know basically a decision stump also, which basically means कि आपका एक decision tree हो जिसमें सिर्फ एक ही root node हो. You split the tree into two parts only. So you can have any weak learner which is giving you better than random guess, even slightly better than random guess. You initialize the weights equally in the first starting, initially, and then you train capital M classifiers sequentially. Okay, for each classifier you do these things. Okay, this is how you're going to compute the error for that classifier, the error rate, unnormalized error rate, and then the classifier coefficient, which I was calling the quality, and then you update the weight for the next of the example for the next classifier. So you do it for capital M times, and finally your output model is computed using this equation, the output prediction. Okay, any question?
सर एम क्या था?
जी
सर वो पीछे पिछली स्लाइड एम जो है वो किसे रिप्रेजेंट कर रही थी? क्या सर ये एम?
M basically सिर्फ iteration number, यानी कि so M is one mean the first classifier, so M2 is the classifier in the second round. So this is, so capital M is the total number of, you can say the iterations, or you can say the total number of classifier you have in the so for example in this case the M is 3. Okay, आपने this is M is equal to 1, this is M is equal to 2, this is M is equal to 3. So for each round you have classifier 1, classifier 2, classifier 3. ठीक है, and finally जो आपका सॉरी फाइनल जो प्रेडिक्शन बनेगी वो आपकी होगी I goes from 1, या M कह लें, M goes from 1 to capital M, M goes from 1 to capital M, which in this case is 3. Then you have the quality or the coefficient, classifier coefficient M, and ym is the output, या hm कह लें, यहाँ हमने hm कह दिया, ym कह लें, output of the m's classifier on the data set, and this is how you're going to compute the final output. Okay, whether you have to assign it plus sign or negative sign. So the m is simply this you can see the classifier number or the round number or the iteration number.
सर ये डिसाइड कैसे करना कितने राउंड हमने लेने हैं?
So these are all, again, this is a hyperparameter. Just like other things, this is up to you or whoever is using the algorithm to decide. And you decide again, hyperparameters, if you remember, you use the training and test set, a validation set to intelligently select the right amount of M. So you do not overfit, तो वही टेक्निक जो हमने पहले हाइपर पैरामीटर्स को चूज करने के लिए यूज की थी, वही यहाँ भी हमने अप्लाई करने को तरीके से हम यूज करेंगे. Okay, so If there are no further questions, then आई थिंक ये टाइम भी हमारा जो है वो हाफ एन आवर ही है क्लास